Problem number 1. If the soil sample has a dry unit weight of 19.5 kilonewtons per cubic meter, moisture content of 8%, and a specific gravity of solid particles is 2.67, calculate the following: the void ratio, the moisture and the saturated unit weight, the mass of the water to be added to a cubic meter of soil to reach 80% saturation, and the volume of solid particles when the mass of water is 25 grams for the saturation. So first is we are asked to find the void ratio and the total volume of the sample. And the equivalent formula for that is the weight of the dry sample is equal to the specific gravity of solid times the unit weight of the wet sample, which is also equal to 9.81 over 1 plus E. We just need to substitute the given 19.5 is equal to 2.67 times 9.81 over 1 plus E. Multiply both sides with 1 plus E in order to find the value of E. That would give us 19.5 E equals to 26.19 minus 19.5. After that, we will be dividing both sides by 19.5 in order to get the value of E, which will be 0.343. After solving the void ratio, we will now solve for the moisture and saturated unit weight. So we have a formula of the unit weight of moisture. This is equal to the unit weight of the dry sample times 1 plus the water content. And we will just substitute the values for the unit weight of dry sample, 19.5 times 1 plus the value of plus the value of our moisture content, which is 0.08. That would be equal to 21.06 kilonewton per cubic meter. After solving the unit weight of moisture, we will now solve for the saturated unit weight, which is equal to the dry unit weight times 1 plus the saturated water content. First is we will solve for the value of the saturated moisture content or water content. That would be equal to the void ratio over the specific gravity of solid, and this will be equal to 0.343 over 2.67, giving us 0.1285. In percentage, the water content is equal to 12.85%. So now we have the value for the saturated water content. We can now solve for the saturated unit weight, which is equal to 19.5 times 1 plus 0.1285, giving us a value of 22.005 kilonewton per cubic meter. After that, we will be solving the mass of the water to be added to a cubic meter of soil to reach 80% of saturation. We will be using the formula again for the moisture unit weight, which is equals to dry unit weight times 1 plus the water content. So to solve for the water content at 80% of saturation, we will use this formula of saturation times the void ratio over the specific gravity of the solid. giving us 0.8 times 0.343 over 2.67. And this will now be equal to 0.1028 or 10.28 in percentage. And now we have the value of the 80% water content. We can now solve for the unit weight of the moisture in saturation, which is equal to 19.5 times 1 plus the 80% of water content, which is 0.1028, giving us 21.5 kilonewton per cubic meter. Now we will solve for the mass of the water to be added, which is our calculated um, moisture unit weight 21.5, and the previous calculated moisture unit weight with a water content of 8%, which is 21.06 divided by 9.81, which will now be equal to 44.85 kilograms per cubic meter. For the last problem, we are asked to find the volume of solid particles when the mass of water is 25 grams for the saturation. We will be using these formulas. The weight of the water is equal to the mass times G, which is 9.81. And we have the uh, water content for the saturation is equal to the weight of the water over the water content, and the volume of the solid, which is equal to the weight of the solid over the dry. So now we will substitute the given values to our formula. The weight of the water is now equal to 25 times 10 to the power of 3 for it to become kilograms times 9.81 over 1000. That would give us a value of 2.453 times 10 to the power of negative 4 kilonewtons. So we can now solve for the saturated water content, which is equal to 2.453 times 10 to the power of negative 4 over our water content, which is 0.1285. That would give us 1.909 times 10 to the power of negative 3 kilonewtons. Now, to solve for the volume of the solid particles, we need to find first the unit weight of the solid, which is equal to the specific gravity of the solid times the wet sample's unit weight, which is equal to 2.67 times 9.81, which is equals to 26.193 kilonewtons per cubic meter. We now have the values to solve for the volume of the solid particles. We will substitute the saturated uh, moisture content over the dry unit weight. And this will be equal to 1.909 times 10 to the power of negative 3 over 26.193 equals 7.288 times 10 to the power of negative 5 cubic meters. So that is the answers for the problem number 1.